Last class we have seen on sustainability. Because you had project, I started with sustainability. And then the sample project, I told you I can give you a sample with assessment, everything. And better I do after completing some portions for you, CLO 4 and 3 and 4. It's important for further assessment. Let me go through one or two classes, then I will do that part which you are already doing in your project. Keep doing, keep submitting your questions. I think you are submitting your questions already. Let me go through later and then give my answers if there's any new question. So far I answer all the questions for you. Right. Let me start with today's class on engineering design for problem solving. When I say engineering design, what comes to your mind? What kind of a design comes to your mind? It will be of either planning. The design is not just straight away starting with the design, isn't it? It will start with the planning, drafting. It may be complete drawing, maybe sketches or draw to scale, and then you go for your original drawing, followed by your detailed design, the dimensioning, right? Each engineer, right? Chemical engineer, they have their own design details. Civil engineer, mechanical engineer, right? They have their own design. Let's see. Now today I'm going to teach the general procedure for engineering design. What should be there in any engineering design, and that is meant for problem solving. Okay, coming to the word problem solving technique, there are so many problem solving techniques, right? Can anyone tell me any type of problem solving techniques that is there in the that you followed in your other modules or other problem solving in your own class, I mean subjects, area of research or projects, coursework? What are the problem solving methods? How do you solve the problem? There is an issue, right? For engineers, it is always an issue of failure of the design or demolition or reconstruction, right? Maybe an issue or a new project or refurbishment or renovation or reconstruction and so on, right? What kind of problem solving methods you can adapt in your own designs in the past? Just throw some highlight and then we will discuss detail today. Problem solving techniques. The scope of study is on engineering design. Eventually, we also see all these designs are targeting on solving problems, right? You must have a number of methods, but I'm not going to teach the detailed methods. At the same time, you should know for what you are designing. That's why I'm asking, is there any problem solving techniques that you followed before? Methods of problem solving, quickly. I will correct you, don't worry. Number one, analytical, right? You have equations. Just by using equations, you can solve your problems. Another one is by using computer models, computer software. You can adapt computer software to solve, to model, design. You first assemble all your data, right? Key in your data, and then you only 103. So for is poor attendance. You should have a practice of attending classes on time. Otherwise, I have to close the attendance early, right? If you're not doing like this, must attend on time. If you want, we can leave early, but starting time should be correct. It's a good practice for you, right? So either you do by analytical or by your software or by graphical. Just by plotting graphs, you can see how the variations, how the distributions, whether a particular phenomena, the parameter is increasing versus another parameter, which is also important and essential in your design. And then graphical method, analytical method, computer-based method, intelligent method, many others are there. In all, you have to design your uh, problem. You have to design, have a procedure, must have an approach, strategy to solve. How to do that? How to have an engineering design done overall? It is applicable for all types of engineer, the basic and fundamental things that one have to remember and adapt in your design is here. Start with the engineering design steps. The steps can be adapted by having this nomogram or an acronym. It's a acronym idea. You should adapt idea in your engineering design, then your design is complete. What is idea? I stands for identify, D stands for develop, E stands for execute, A stands for assess. You must adapt these techniques, and each one have subheadings and 2 or 3 subheadings to follow, to develop, to understand, and then adapt in your design. Let's see one by one. Identify the problem. For anything, you should have first know the problem, right? It may be of a failure of a dam structure, or construction of a new eco city, eco park, or firewall, bank robbery. You have to solve the problem of bank robbery by having a very good firewall. Or if it is mechanical engineer, maybe pipe burst in their oil refineries. Suddenly one column removed, suddenly one beam broken, damaged, pipe bursting. All these things are the problem. First, understand the problem. What is the problem? Is it a pipe burst at the place or a different place? Understand the statement and the statement of the problem first, and then gather the information. I will read the titles now. Later we'll have paragraphs for each to discuss one by one. Okay. Logically, you must know the identify the problem, right? Understand or define the problem first, then gather needed information. There are supporting information, data with which only you can design. So collect all the information. If it is a new construction, collect all the background data, basic data. Start from survey of the land. If it is a new project, if it is a computer project, start surveying what is the high-end computer that is required, the configuration, the technologies that is required, and then the manpower, everything, right? And then gather all the needed information. Searching for creative solution. Yes, the old solution have been applied already, and that has proved to be failure. That's why we need to have a new project, or you have to address the problem happen in the old designs, the traditional design. Like you have now traditional way move to transit to sustainable way. Sustainable way is an innovative way, right? All the ways are changed into innovative material, which will be turning into cradle again, like money, turn into a money or fruitful thing. Like that, you have to have a creative solution. Otherwise, no, don't do any engineering design which is not having any creative. We cannot say everything should be creative, right? But at times you have to follow the old traditional way. Maybe the company is always doing this conventional, taking only projects on conventional, traditional building design, or projects on pipe networks or treatment plants or any other construction type, or maybe erection or company uh, tools and machines type. Any type of project, they may be having the traditional one. In that case, it is unavoidable. But if it is a growing company, right, top class company, top rank company, they always go for creative solution, which is benefiting, which is improving their market, which is improving their GDP of the country, because they are all representing the country's GDP. So they always look for creative solution for each and every design. And hence the employees also must be of that kind to think of creative solutions than the traditional solution. Alternates and better solutions. Alternates would be better solution than the previous. Overcoming obstacles of to create thinking. Right. When you're doing so, you got the statement, you got the information data, and you got the methodology to solve, and then find out the risk and reliability, and also the threats underlying the problem. What are the obstacles? What are the constraints, right? Maybe political constraint, economic constraint, or material constraint, or um, the knowledge or expertise may be limited in that region, or maybe there is a war going on. There is a um, pandemic going on, there is an epidemic going on, we cannot overcome, or change in political setup, many other factors are there which can directly affect your project. So find out overcoming obstacles to creative thinking. You must understand the constraints and try to overcome. How to overcome? Must have an approach or an idea to do that. Moving from ideas to preliminary design. Once you have done this part, identify the basic information is data, creative solution or methodology, and then the obstacles must be well known, or you must have an expert who can guide you through overcoming obstacles. With that, you can have ideas moving to preliminary design. Evaluating and selecting the preferred solution. Once you define the, come out with a design, you must not just like that going to implement, right? You should evaluate. Like you had injection, right? COVID-19 injection. They have tested with species, they tested with animals, and then with sample selected human being, and then only it was implemented, it was used by the people, public, common public. It was standardized, right? Then only it was standardized and then brought to community purpose. Evaluating and selecting preferred solution is most important. Preparing reports. Now your job is done, you are implemented, you are evaluating, and it's successful. Now everyone can use it, and the project is commissioned already. Then what you do? Prepare report, plans, specifications, right? Yeah. It may be the line, this line may be preparing a report, maybe somewhere here. It may be after completion or after completion of your desktop work, right? Table work, and then you prepare plans, specifications. If it is a construction work, this line will be bit varying. Sometimes it is coming before or after. But once you come out, this line may be somewhere here, right? Design. Maybe interchange 6 and 7 way interchange in some places, some kind of designs. Now preparing reports, plans and specifications, right? You have to, based on all these things, prepare your report, the execution plan and the specifications, terms and conditions, agreements, whatnot, all are related to the project planning. And then implementation or implementing the design, right? Once your report is gone to the executive engineer, if it is a government project, they will approve and you start implementing the project. Finally, you cannot just implement and let it go. Must have a continued monitoring, right? The engineer in charge must be continually monitoring to see ongoing project, post-project evaluation, to troubleshoot, to improve if there's any flaw. Some of the things you can only know after use, right? If it is a product, food product, or any consumable products, must be monitored to make it perfect and permanently launched into the market. Next is identifying the problem. Any questions so far? I just listed out the design steps. How to do the design steps. I repeat. Yes. Okay. There are 9 steps we have listed down for a design, engineering design. Identify, gather information, search for the creative solution, understand or overcome the obstacles, move the ideas to preliminary design, evaluate and selecting the preferred solution, preparing reports, plans, and so on, and implementing, finally monitoring. Remember this point, right? Identifying the problem. In identifying problem, now we are going in detail about each and every topic. That is what the whole subject or scope of this engineering design is. Let's see one by one and what are the things to know or undo, or do and undo, do's and don'ts, and monitoring, right? Or follow up. Identifying the problem. Number 1, problems and needs should be stated in the objective terms or specific terms as much as possible. It should cover, yeah, the problem statement or the question, right? Research question or definition of the problem should be very specific, because you're engineers. You cannot say good, bad, yeah, very good, very worse, dangerous, hazardous. No. How much hazardous? How much crisis is there? 80% crisis, 80% market down, 20% improvement, 50 people, 50% of people affected. Like numbers, quantitative numbers should be there. Definition should be very specifically given. Like, how is it? You just follow the acronym SMART. SMART stands for specific, measurable, achievable, or attainable, relevant, and time-based. Always remember this point when you define the problem in the very beginning of your design or doing a problem statement. So must be specific, measurable, go to the point the where it is the problematic, right? Very specific one. Don't say the whole system failed when there is a flaw at fourth level only, right? And fifth level only, or at execution time only. There is a module missing. There is a program running. He has installed software. He is running the program. At running time, he missed out with the one family itself, one family package itself, or the icon itself. Like that, you see where is the problem exactly. Measurable, must be quantifiable. Not measurable also there, in it is exceptional, especially in natural events, right? Natural phenomena, natural events, or new inventions. Sometimes not measurable, but most of the cases should be measurable, quantify it. Achievable and attainable. This is also not true for all, but make sure you are achievable. Not achievable at the end. After all, you have done the research and then come out with a design saying that it is not achievable is also one way of answering. That is what we say for postgraduate students and PhD students. Don't say that you have to achieve it. If you take up a project saying that my design is going to achieve 100%, it may fail. Then you come out with the theory saying that if with these combinations are there, this is going to fail. Failure theory. This is also important to caution the engineers or your followers, your readers to understand what kind of parameters and factors going lead to you to fail the project. So you're cautioning, you are making the people aware of this. So still, uh, exception for few projects. Achievable but overall should be achievable and attainable. Must be relevant to the region, relevant to the community, relevant to the problem concern, and then time based. Cannot take some years together. You must have some smart people, quick working people, and quick efficient people to be employed and then get it done within the time frame. Like if it is a irrigation project, supplying water to the lands, you must supply the water during its nursery time and then growing time. You plan everything and implement, and the project is started during harvesting. Only you can send the water, supply water only during harvesting means it's wasted already, right? Must have on time and efficient. Efficient, the word efficient is quick and precise, right? Must have efficiently utilize your time to divide. I mean, the project Gantt chart. Later you will study in project management about Gantt chart, how to prepare Gantt chart, what are the variables there. That time base, that time planning schedule should be specific, achievable, and at the same time reaching on time, not at the wrong or delayed or at the inappropriate time. Problem definition in objective terms. Yeah, example one is here. We keep saying be smart in identifying the problem, right? How to be smart. There's an example one, the usual example we give. Design, and say the two different definitions are there. Say person A, student A defined this way, student B designed this way. So which one is correct? Did I give here? Which one is correct? Just read, have a read. One of you read the first one. A problem is defined. Can anyone read the first paragraph? No one there. All joined and left. Just keep it on. Is it 126 students? What happened to remaining 15? 15 students not yet joined. Now the time is 2:20 already. I don't know what's going on. Please join on time. Can anyone read this? Let me call. Don't mistake me. Ali, Ikmar, Kimiji. Kimji. Ali, unmute and read the first paragraph, please. Ali Ekmer. Kimji. Are you there? No? Okay, next. Chang Kai Han. Chang Kai Han. Not here. Why?
Yes, Miss.
Please read the first paragraph loudly.
Design an energy absorption system that will control the energy of a crash of a 2,500-pound car traveling 60 miles per hour. The device should be no longer than 10 feet and should cost not more than 10,000 per unit. The deceleration should not exceed 6 grams.
Gyration, the radiation mean the rotation. Okay, thank you so much. Right, very good. See the statement here. Everywhere it is specifically written, measurable. They have already designed, right? There's a statement saying you have to design a car such a way that design energy absorption system. It's an energy absorption system in such a way that it can crash the energy. The car's energy is about 2,500 pounds in terms of kg it is given, right? Kg is a mass only, it's not at weight. Some pounds, some mass is given to you, and then it is traveling at 60 miles per hour. See the traveling hours. Normal speed are not very high and should no longer than 10 feet. The device should, there is a constraint, they cannot accommodate more than 10 feet long, right? If it is a towing tank, normally the towing tank designed for any type of analysis, testing, laboratory, they go for hardly 10 meter. Here 10 feet, 10 feet is less only, but 10 meters is the highest one that they can accommodate inside the lab to monitor. A man will go in a jeep or just traveling through some vehicle to one end to another end to monitor it. In that case, they design only 10 feet, the requirement, not more than that for this purpose. Cost should be this one within the, say there is another, you can otherwise call this as a constraint. Constraint, it is quantified. Lastly, deceleration, design constraint, this is a 6 gyration only. You cannot be more than that. So all these parameters should be there in your design very specifically. This is a very good example for a design for which they are designing a energy absorption system. The same way, see here, the gentleman B has written this way. No information at all, just fast speed, and then should be short, not expensive. Deceleration should be not be harmful to the driver. That's it. There is no mention about any parameters. Like this, please beware of when you do your design definition problem statement, either in your capstone or if in future, make it very specific. Have a plan. By reading many materials, you will know, you'll have some idea to do that. Now come on, gathering needed information. So number two, we are at number 2. Always remember this idea. 7.9 points, I think. Always remember these 9 ideas, which is 2. Now we are at 2. Gathering needed information. The needed information could be physical measurements, maps, results of laboratory experiments, patents, results of opinion surveys, or any number of other types of information. Yeah, you have to have a raw data, right? Feed-in data. Database is very important for any problem. It may be a new problem or a problem solving or solving a crisis for a community or for people, right? Or for children or for adults. In any case, you need a data. How do you grasp data? Physical measurements. This is time consuming, right? In some cases you really have to go to, if it is a medical related, inpatient related, you really have to go to the patient side and make the measurements to analyze. And then maps, if it is a natural related, right, geographical related, get the geography map. Nowadays a LiDAR map, and then many technologies are available for mapping, and they are keeping updated. You can approach the departments to the respective department. If it is related to population, go to economics department. Environment department. Anything related to industry, go to Ministry of Works or Ministry of Factories, right? All this type of, it is depending from region to region. you have to approach the respective department to collect your data. It may be map or point data or any type of any form of data. And then sometimes you have to conduct the experiments at the laboratory. If it is an environmental lab, they will erect the column, they will give time for digestion, they will give time for growing enzymes, and then all these things are observed, and that's going to be the basis for their data. It might be patents, right? This is very important. When you do your project, please remember to see what are the patents registered recently, granted recently, so that you'll know what is the current technology as on today. And having done everything, in future also, if you take any 5P or any future projects, please remember to go through this one. The department is lens.com. Later, I will put in the chat box, lens.com. If you go through that, you will find all the royalties, patents, royalties, and then trademarks, copyrights, all the things are registered there. You can check under each heading. It may be of any problem, maybe civil engineering design, mechanical design, or computer design, any design. They would have, you know already what is patent, right? I don't have to give an explanation on that. You can check what is the current situation, the opportunities for further research. Don't do what they have done already, so you have to extend it or make a new one. This will enable you to understand. This is also a kind of a data that you should gather. Results of opinion survey, yeah. See, nowadays, starting from the SDGs, when I teach the SDG class, it will be, you'll be knowing more information, or you might have read so far, right? You're doing projects. Nowadays, it is not no more a project, a company, a country. It is global, must have a global thinking. In doing so, you must have the expertise. The expertise are the local people. Must any project, any invention, any design, any factory must satisfy the needs of the local people of that community, of the country, of the region. So local people, their knowledge, their experts survey, right, their opinion conducted by their knowledge which is gathered through the questionnaire survey or opinion survey, expert survey will be the best for your projects. That could be that could form a basic data for your project. It is also useful, and sometimes people use this for evaluating. Either way, see, this is whole data collection method. You keep half method for your processing, designing, analyzing, and the half method for your evaluation. Like you collect the maps to do your development of the model, analyze, design, and then use the expert survey to evaluate. No evaluation, no publication can be done. No database can be captured in from your publication. So the best publication always will end up with evaluation of your design. Any number of other types of information. So apart from this, any type of information that you may collect through departments, people, like there are, you will learn when you go for actual projects, you will learn primary data, secondary data. If you collect from data from any other sources that already utilized by people and published, then it becomes a secondary data. You can still depend on, in worst case or where the data are very scarce, you can still depend on secondary data. Right, information on related problems that have been solved or unsolved may help engineers find the best solution. Yes, you must collect directly related problems data or dependent and independent data which are directly relevant to the problem to be solved. Then only you can find a best solution. Don't go for abnormal or outliers, and we call it in computer terms outliers. When you plot the data, right? When you plot the data, you will get a nice bell shape or nice increasing or decreasing or a kind of a parabolic curve. But you may see some points lying outside the curve, inside the curve, very abnormal behavior. Outliers, they call this as outliers. Remove all the outliers, understand the major phenomenon, the process that is taking place, characteristic curve that can help you to understand the process and proceed further, right? So like that, collect the relevant information, number one, and within the data also you should remove all the unmatching or irrelevant information inside, outliers. Okay. Searching for creative solution. So you got the data, you define the problem, you got the data, now go for methodology to solve. you get methodology in a creative way, a new methodology, that will end up with a creative solution, right? It's a direct proportion. Some techniques in finding a creative solution or brains, how to get a solution. In the beginning, as I told you, problem solving method. Problem solving technique can be just using existing equation, or by graphical, or by computer based software, or by using the existing models like MATLAB. If it's a computer programmer, use MATLAB. The engineering software, you can use, I don't know about mechanical, I have zero knowledge, I'm sorry. You can take up your own software in, or the general analysis software, if you take ANSYS, and then ETAB, Esteem, Revit analysis software, and then computer programmers, mainframe database, what big data nowadays, big data, all these areas you should be knowing and find out which methodology is going to give you or solve the crisis that you have taken to solve. Okay, how to do that? Here some information is given. It's all from borrowed text material, I think. So you just follow as it is. But on top, you can have your own methodologies to solve. What is it here? Obtaining a creative solution. Brainstorming. You can have a brainstorming, yeah, to get information, knowledge from the locals, or to start with, right? To start with, to know current scenario, interests of the people. It's called market survey, market survey. For market survey also, this type of brainstorming will be very helpful to know what is the trend, whether there is a niche, checklist, attribute listing, the force relationship techniques, and adapting a different point of view. Okay, brainstorming, you may conduct a forum, right? You throw question and ask the opinions from all others, wait until they all finish. There are some conditions that also you have to fulfill. In the next paragraph we will discuss that. But you can have a forum discussion checklist. You have a checklist to check whether all points have been completed or not, all questions are done or not, by conducting a questionnaire again. Attribute listing, by listing the attribute, right? You may know which is dependent. In English, in engineering terms, I say, if imagine you don't have an equation for solving volume, simple one, volume of a cube. There is no formula for existing for volume of a cube. Imagine our engineer, engineer Chan, or I don't remember any name, sorry, because we had very few classes. Engineer Ong Zing Yi is going to develop a method, a new method for finding the volume of a cube. In that case, what he is supposed to do? He will be using this technique, right? Attribute. He will gather all the data, dependent data, radius, volume, radius, height, size, cross section, diameter, length, breadth, width, everything will gather. But he has to know which is directly dependent, that variable that is directly relevant to him, and then find out which is dependent, which is independent, which is slightly varying, right? All these things you have to list out. The attributes have to be listed out according to the importance. Sometimes there are problems which are non-linear. You can treat initially as the linear. Later you can add the variable of non-linears one by one to check. That is also possible, because you cannot straight away work on the non-linear variable, right? Assuming, having some assumptions, start your new project with linear interpolation or linear curve fitting method, a simple linear equation. The later can be changed to non-linear. The force relation, in doing that, when just now I say most of the problems in reality, in practice, are non-linear, uncertain. In that case, you can have force relationship technique. You can forcefully say some of the variables are not changing, constant, not varying, not changing, normal. All these things you forcefully make it constant or make the relationship smooth, not varying, then you can have a solution. And adapting a different point of view. When you do that, the solution may be you don't end up with any type of solution. Adapting a different point of view, that is having a very good meaning in it. The solution, you can have different cases, different methods to solve, different approaches to solve. Finally, you decide whichever is feasible and suitable for that particular solution. Right. In doing brainstorming, these are things you have to take care. You have to encourage and record all ideas, right? You really have to be very patient, skilled, matured adult. You cannot be throwing your own ideas into that people because you are there to collect their information. Brainstorming is done for getting others' opinion, others' knowledge, like you are copying. When you copy, just keep quiet or keep modest when you talk to people, collect information, encourage at the same time, encourage when they do correct, give correct answer, encourage them, give them lead points to start. If they are timid, give them lead point to start, encourage and record all ideas. I have to record all ideas, right? You for not missing, right? Not missing or become incomplete data for you. Better to record. Include all those that appear completely impractical. Yeah, yeah. At the moment, when the people saying sometimes it's unreasonable, unreliable, unacceptable, just record it. Later, you can filter out. Don't give opinion or answer or evaluation at the moment itself when you are gathering information from uh, people or forum or through brainstorming. Do not allow judgment or evaluation of, yeah, it's already here, evaluation of ideas during the idea generation session. Should not evaluate us. Yeah, you're right, you're wrong. No, don't interrogate or when no, not negotiate, negotiate at that time. Avoid negotiation or arguments. Debates have to be avoided because you're recording. You may have another session to debate if you really need. Make it as a debate. But for now, gathering information, you should really have better, collect everything so that you can come out with a creative solution. It is important to generate as many ideas as possible. Right, I have to say one thing. I don't think I'm deviating from the topic, but it's important. When you do your project, don't do yourself like, especially the individual people, individual students. Even if you are in group, your topic you are doing yourself. Please talk to somebody, recite to somebody, speak to somebody, present to somebody that I'm doing this so and so. So while talking itself, it may be anybody, your elders, grandfathers, grandmother, or maybe the brother, sister, younger or older, anybody, just present to them. When you talk to them, you'll get an idea, right? Especially when you get stuck up, when you get complicated, cannot move on, not clear, talk to people, present to people, you will get idea. It is for sure, it has happened in many people's life. You cannot be doing always your own. Must interact with people, you get ideas. Right. This is apart from this, but I'm telling you, this idea to overcome your difficulties at times. At times you get fed up, you feel like no way, lost the pathway, right? Lost the how to move forward, all these things. You just talk to them, you'll get an idea. It is important to generate as many ideas as possible. Encourage people to build upon the ideas and others. Yeah. So you give lead point or get one, start the point and ask the other to, contract, right? Reply, get the reply. So like that, you have to be a good mediator or a facilitator of the show. Evaluate the ideas after the session is completed, right? Right. When the session ends, you can start your evaluation of the ideas that was collected before for getting the better solution. So it's maybe this topic is only through questionnaire, right? This problem can be solved only through questionnaire. These are things you have to adapt. Solving problem. If it is computer based, slightly different, all depending on computers. Do effectively make use of the modeling stages so that you'll arrive at the right solution. Okay. Search for creative solutions continued. Some more. Number one is brainstorming. Another one is checklist. How do you do the checklist for your creative solution? Creative methodology also same. One of the simplest methods for generating new ideas is to make a checklist. Yeah, you cannot remember everything, have a checklist. Or nowadays there are many monday.com, sunday.com, many modeling, many what you call planning softwares are available, and you can make use of it while you do your project to have your checklist done and then handle it. See, nowadays trillions and trillions opportunities are so high. Tsunami, we say. One time I heard people, tsunami of opportunities are there. But how much you can utilize, how much you are effective. Individual evaluation is also important. Think yourself how much you are effective, how much you can utilize. This comes by practice. You have to take part in not tsunami, at least small rain you take, and then analyze and be part in the globe, the planet. The checklist encourages the user to examine various points, areas, and design possibilities. Yeah. When you have a checklist, you can order, right? You can have a classification. You can have the design is not one step, right? It may have many folds, logical steps, applying codes, applying ethics, applying, when I explain the projects also, you will know how many ingredients are there inside, are there receipt, are there in a design. It is not one step. Number of steps, start with the strategy, what are the standards, ethics that you're going to follow, what are the criteria, what are the methods, what are the data, what are all the formula, principles that you're going to adapt, and what are the directions you will have, and the solutions, right? There are many steps that you have to remember to adapt. In that case, checklist will always help you to address the issues. If there is any troubleshoot required, you may know which level is it, whether it is at the last conclusion level, or at the load case, or at the or any fifth line, sixth line, if it is a coding program, sixth line or 100th line, all these things can help you. With attribute listing, all the major characteristics or attributes of a product, object, or idea are isolated and listed. Yeah, the same thing I can say. Checklist, you should have a list of things done, whether you gathered, you checked, and then it will also help you for improvement wherever any problem occurred. Similar case, attribute listing. The checklist is under categories of parameter. This one individual parameter itself, attribute itself. Like if you take your project, SDG project, it may be SDGs. Checklist maybe what are the SDGs you're going to cover. This may be what are the under SDGs, what do you have? Under SDGs, what do you have? Attributes maybe. Come on. I don't know. A silent show. Under SDGs, the attributes may be, variables may be. What is going on? Silent. 131. 10 people missing. Attributes may be targets. And inside targets you have, you can call this as a, what do you call the, asking many times I forget. After, under targets, what do you have? Hello, are you there? Indicators, or what is it? All these things are coming under attribute listing. It may be a kind of a target, or under target you have identifiers. All these things can be listed out. Please respond. Are you tired? Had your lunch already? It was at 2 o'clock, right? I hope you had lunch, but don't take big lunch, light lunch. You know you have classes, please take light lunch or some coffee or some kind of energizer, right? That too is theory. You just attend the class, no need to prepare afterwards. Grasp the ideas only. Okay, attributes may be your the goals, the targets inside 3.11. If you choose 3.123 will be your attribute. And inside got another identifier or classifier, or what do you call this, is a indicator that can help you to prove that I can do this, it is solving this, it is helping this, it is breaking this. It can be not, it is always not a reactive thing. It may be suppressing thing also. The attribute can be of good or bad. If it is in microbiology, good bacteria or bad bacteria, both it might be. So you have to analyze all of them. For each attribute, list ideas as to how each of the attributes could be changed. Yeah, once you get the attributes, automatically you're going to plot and see, either plot and see, or you develop, do experiments and see what's the variation, relationship between them, and so on. Such a creating solution. Last two things with this is over. Okay. Now, forced relationship techniques. Yeah, as I explained before, takes a fixed element such as product or some idea related to the product and forces it to take on the attributes of another unrelated element. This forms the basis for a free-flowing list of associations from which hopefully new ideas will emerge. Right? That is what I explained before. You cannot take all the variables subject to in your model. You will get some pages and pages of errors. You will lose your life or lose interest if you do subject design for the whole parameters and the variables, right? If you are going to design a new prototype for handling, the crisis today, I'm afraid not to go deviate from the topic, otherwise I cannot complete. You can see very good examples. The like recently the one what unmanned drones drones and others which are working as a post office, and they are carrying the post, they are delivering even into the pigeonhole. There are very good designs, new designs, which can reduce the human intervention, right? IR4 technologies, drones carrying the post and delivering into the pigeonhole of the particular condominium or direct flow, I mean the residential building. In that case, there are a lot of constraints, a lot of variables involved, right, in designing it. Initially, they would have started with assuming that it is flowing on the ground, right, on the ground or just a short distance or carrying nothing, and then add with some materials. And the kgs also matter, right, how much kg it can carry, the capacity, all these things they have to, because it's unmanned, it's a highly risky project, unmanned, which is going to fly. So they have to take care of each and every element. So what they have done, they would have started with the linear approach, basic approach on ground, and then to some height, and then to outside. So gradually they have to improve on by adding the variables and adding the non-linearity in the project, right? With that, when you do go stage by stage, you will also get new ideas to go for next level. That is how many good technologies are existing today, and we are enjoying. People sometimes, as of now, you can all think of these kind of approaches are important for new projects, innovative projects. If you talk about, go back to the same case of sustainability projects where you make waste into useful product, you really have to think stage by stage. You cannot get in one stage. You will come out with, initially you add some chemicals to get better material, right? The waste that is obtained from any food production or manufacturing, you started with adding some chemicals, you end up with one product which is viable or non viable. Again, you test it, you read more, understand the phenomenon, the variations, keep modifying, keep improving the design. With that, you will be able to achieve a good product. In that case, some of them you are assumed to be constant, not varying. All these principles have to be adapted. People sometimes stretch their minds by adapting different points of view. Yeah. So you have to be, simply saying, you have to be open to, if you achieve, that's fine. If not achieve, also have to be open to the new ideas and the crises that have been studied and identified through this project. You must have a kind of broad-minded, right? Broad-minded approach in facing the solutions, in analyzing the solution, and move forward for a better solution finally. So we must have people sometimes stretch their minds by adapting different points of view. Initially, you might have example. Initially, you might have set for 100% efficiency, but you end up with 60%, right? Then you improve it, have some liberal, provided everything and other factors are also contributing to it. With that, you can achieve 100%. Overcoming obstacles to creative thinking. Right. When you do these type of forcing technologies, right? Brainstorming, all the previous steps in collecting information, getting the best methodology to get the best solution. You have a lot of obstacles, constraints. What to do? Avoid placing unnecessary constraints on the problem being solved, right? Yeah, for this you must have a knowledge, good knowledge, background, idea, information read or learnt before. Then you avoid unnecessary constraints. Search for different ways to view the problem. Avoid preconceived beliefs and stereotypical thinking, right? Yeah. You may not be having a same one solution for certain problems. You'll have different solutions, different approaches. Still, you have to go through it, and then don't have a belief that stereotyping means it's repeated one. Don't have the don't aim to get the repeated solution or same solution for every iterations, right? You may have to keep improving on it so that you have a different way or better way. In other words, a better way of viewing the problem is important to achieve your solutions. Recognize that there are non-engineering solutions to many problems. Consider approaches that other disciplines might use. Yeah, and that's why I say number one, you talk to people, right? That itself is multidisciplinary people you are meeting with. Another one, for getting solutions, especially you're doing your master's by research or PhD by research, your FIP project, right? Some people, they really focus and they're very serious about getting a new idea, taking a new project, right? In that case, you have to have read from different areas. Don't look into same. Go for allied field, have a reading. It will throw some light, trigger on some other ideas in yourself. That is what happening, and we also experience so many times. So don't have a same stereotypic reading and then same type of working on the projects. Have a multidisciplinary thought. Either you talk, you do, or interact with, get opinion from people, but don't go beyond. Like you will, if you do beyond it, you become unnecessary constraint. So have a limit, and then uh, same kind of problem, how they or similar kind of problem. See, any problem will have multidisciplinary phasing, right? It will have engineering approach, economic approach, and then microbiological approach, sometimes like some project, or technologies, or normal labors, right? Or labors necessary to complete certain stages of work. All these things are involved. In that case, don't look for only, if it's a mechanical project, don't look for mechanical design solutions alone. Look for thermodynamics. Look for allied things like thermodynamics. What are the thermodynamic publications say? What are projects have been? And then production companies, some other companies, allied companies, how they come out with a solution. Construction company can be a construction company, can be another type of engineering company. How they solve the problem will give an idea, reframe your idea, give some input to your thinking. That's how you have to have non-engineering solutions. Non Recognize that there are non-engineering solutions to many problems. Yeah, there are two meanings here. The number one is the multidisciplinary thinking should be there, reading and exposure should be there. According to this statement, non-engineering meaning some sociological, right? For a project, it may end up with some sociological benefit to it, some sociological uh, dangers. When you touch upon this, then you will encounter this problem. Such things also you have to be careful, analyze and recognize and understand it. Last, few more points on the obstacles. I repeat, we have seen and avoid unnecessary constraints, search for different ways to solve, search for non-engineering solutions, right? Whenever the word non-engineering solution comes, no magnitude, qualitative terms, social, feelings, attitude, all these things are there. And then look for relationships that are remote and solutions that are unusual and non-traditional. Most creative thought involves putting experience and thoughts into new patterns and arrangements. Yeah, you had all the attributes, right? You can play with the attributes and say what are the relation, common relationship. They are dependency on the progress, right? All these things you have to analyze and come out with the new patterns and arrangements. By finding the relationships of the data you collected, you have some idea, you have some, you had overcome some difficulties, right? By like you had 10 variables, by analyzing, by finding the relationship, you say, yes, 5 variables are okay. 5 variables are not much vary. We can still consider to be linear. We can still, it is control variable. So you come out with a solution saying that it is not an issue. It is not, I'm talking about a variable. Sometimes it may be, if it is other type of problem, other type of variable it might be. So you have to, by analysis and the progressive analysis, you may overcome some obstacles. Divide complex problem into manageable parts and concentrate on solving one part at a time. It is also applicable for your life. All students, they will have week 12, you will have number of courseworks to do, right? Courseworks, assessments, projects, submission deadlines, right? Whenever it is like this, and don't think that you have 10 assessments to do. Immediately think that there is one assessment to do. Start doing one assessment. When you finish, you're free, your burden is a little bit reduced already, and then do one after another, portion by portion. There are many good techniques followed. I don't deviate the topic, let me on the track. In that case, as I said, do one by one, part by part. Assume that it's only one part, only one question, only one deadline. You make your mind, solve one by one. At the end of the day, you finish everything. Same goes to complex problem. Break into small problems, right? It may be territorial. I mean, the region-wise is so complex. You have, if you have taken a country, solving country's problem, start from small village, a small road. Go for a village, district, county, and then state, and so on. You can expand slowly. And then in terms of variables also, don't put every variables to analyze. Take 2 variables, 3 variables. At the same time, you have to mind the timing. If it is time consuming, you must effectively handle the time. Eventually you must arrive at a solution or overcome your difficulties already. Allow time for incubation after periods of intensive concentration, especially the period of incubation necessary, especially if it is a sociological problem solving. Give some time, especially political, right? You have to give some time. You have plenty of things to do every day, right? They have different tasks, different meetings. With that, you have to give some information. It is for socialization. Coming to your own problems like environmental, again there is a time given for retention, detention, right? Or what do you call settlement of the waste onto the down, right? Everything they have to wait. They have to allow time for analysis for getting correct answer. Right. Be open to variety of problem solving strategies. And that is there for every step. Be open to strategies. Later you filter out. Later you make it precise. Any questions so far? We have completed how many steps? Always remember these obstacles. We already overcome obstacles. 4 steps you have completed already in engineering design. Another 5 more. We are here. So once you got this everything done, right? Open. Finally, you must you are a problem solver only if you are open to ideas, open to public, accept ideas, varieties of ideas. Moving from ideas. So now you got data, you got analyze, you have overcome all the difficulties, you got a better method to solve. Start preparing your design. Preliminary design, since you had already in the last step, you had already creative design, creative method to solve your problem or do your project, the selected project. Do a preliminary design, evolve through analysis and synthesis. Analysis is breaking apart the whole and studying its individual components, right? Yeah. Start with the preliminary design. Next step is to assemble everything, come out with a solution, right? In that case, you may have equation already, or you may not have equation, or you have some basic equation, basic relationship done already through your last step in overcoming the obstacles. You might have arrived some solutions, some relationship already obtained. Then build your design based on the preliminary step or preliminary design. Start with the preliminary design. First step, few steps, and then synthesis involve putting together many facts, laws, or principles into a whole idea that will accomplish some results or solve a problem. See here, there are two terms used: analysis. Analysis, you do have breaking apart a whole and studying its individual components. Yeah. Synthesis involves putting together many facts, laws, or principles into a whole idea that will accomplish some results or solve a problem. Yeah. Synthesis may be a part of analysis. See, analysis you do, right? Analysis you do. Analysis means you are applying your knowledge, right? You are applying your knowledge, understanding into a topic, into a problem, into a project, into a development or a design. In that case, you can break into component parts. Like if it is a simple example I give you, if it is the analysis of a building, start with foundation analysis. See how what are all the failure factors in small in colloquial terms I say so because you are multi engineers. So just what are the forces acting on it? What are the failures that will occur? What may be the dimensions of the foundation, the piers, sizes, all these things do for foundation first, and then go to basement, then go to superstructure, then go to other levels. So do step by step from the bottom to top approach or top to bottom approach. Either way, section wise or part by part, you analyze it. In each analysis, you may have to synthesize. Synthesize is in each case you have to put have some principles, have some formula, have some assumption, have some equations to be solved, right? With that you may able to the synthesis must be appropriately chosen, otherwise you will not end up with the solution. It is like a your Newton-Raphson method, right? Numerical methods you would have studied, you will not get any exact answer at all, right? Near to optimal, just approximate value only you will be getting. Not like that. You should have a definite value by having proper synthesis at each and every analysis step. Apply all possible and related principles, equations, solution techniques to come out with a solution. Any questions so far? What is the theory? You have to understand and remember these points. Some of the techniques to test an idea are sketching, lab test, research project, and constructing models. Yeah. In the preliminary design, there may be testing. It is not evaluation yet. There's a difference between testing and evaluation. Anybody can tell me? What's the difference between testing and evaluation? You might have adapted in your coursework or what else before. The words, testing and evaluation. In prelim design, you are testing, right? Come on. Prelim design, computer science. What's the difference between testing and evaluation? Any idea, please? Only if you don't. Always about 10 is missing in the class. I don't know why. Now 11 students, 12 students. What happened? Please answer me. What's the difference between evaluation, testing and evaluation? We quite often come across this. And next semester, you may be doing projects, right? When you read, you will have these terms quite often used. First, able to differentiate. But some of the things they are interchangeably using it. But try to have the difference between these two terms, testing and evaluation. Anybody? You can answer, just do not worry. If it is wrong, I will correct it. What's happening? What's happening? Boring. You remind me at last minute. Last time I couldn't spare longer for your quizzes. That's why I'm posting it to the last minute. Like 15, 25, 20, 22, 22. 15, 22, I start the quiz. Until then, we'll discuss about this topic. Come on, answer me.
So the difference between testing and evaluation, right?
Yeah.
Like a testing is like when the product they do some test to it, where evaluation is the result from the testing.
No, but good attempt. Appreciate. Any other? Not like that. Two different things. Any other? Come on, civil engineer, environmental engineer must be having, might have come across this type of problems.
Miss,
Yeah.
evaluation is more of like a process of examining the problem, and testing is like one of the way to evaluate something.
Oh no, you use the same term in both.
Okay.
Your answer seems that they are both same, right? You use the word evaluation in both. Must be different, lah. Any other
Yeah,
good attempt?
evaluation is more like a
Yeah, here, right?
You can check the chat.
This one, come on. Testing. Let test. Chat box. Okay. Let me check the chat box. Somebody say answer the chat box. Interesting. Evaluation is making judgment based on the evidence we got. Correct. What about testing? Ahmad, Mahmoud, June. What about testing? Okay. Evaluation definition is okay, acceptable. Okay. You are saying the output, but I'm asking how you conduct and how do you conduct and what is the difference between testing and evaluation. Okay. Last one. If not, I will give you the difference. Okay. If it's a product development, say product development, it's a very common for everyone. In the product development, you have some data, right? You have some data you already collected, you are developing it, and you are design already, you construct already, everything done. The testing will be the examining the performance using the known answers. Give the input and see whether the required output is obtained or not. That is called testing. You know the output already. You test the designed product or vaccine or methodology or system or a policy, knowing the answer, right? Evaluation means for a new input. Evaluation must involve you give a new input for which you don't know the output at all, right? Really, it's a new input, new. The output should be, after getting the output, should be matching with or relatively or proportionately, it should be tallying with the testing. In this case, the testing will always have a higher percentage than the evaluation. Evaluation will always be lower than the testing. If I achieve image processing, if I achieve 98% in testing, I will achieve only 90% in, but nowadays it's 100%, nearing 100% depending on the modeler. I'm just telling you an example. Evaluation may be less than that, like 90% only, because the new data, new set of input, your model is responding to the new set of input and you're getting new output, isn't it? So that is how you have to differentiate and do stage by stage your design and testing and evaluation. Okay, right. Followed by mathematical models usually consists of one or more equation. Yeah. Uh, that describe a physical system. Many physical systems can be described by mathematical models. Yeah, these are all the things. Moving to ideas. One moment. Together. So, moving ideas to pyramid design. We said design. After you get the methodology to solve by brainstorming and so on, you have to move your ideas, your methodology into a design, into a prototype, into a product. In that case, you can follow this thing. Either you do the simulation model or a physical model or a mathematical model. Okay. An engineer Bottulu, I remember Bottulu is saying here, TL, what is, who is TL? One moment. Engineer Bottulu is designing about engine, right? Multi-stroke engine. In that case, efficient engine. Electrical, nowadays electrical motors are very common and important in sustainability era. But at the same time, performance should be good, right? Performance should be equivalent to the other type, non-renewable energy sources, right? In doing so, he will have mathematical model. He can have computer simulation model, physical model. He can choose mathematical model to develop the equation, relation, come out with the relationship by testing and experimentation in the lab, maybe in the real model or in a computer model. He can do either follow this step or this step, computer simulation. And then the physical model can be for evaluation or testing. Vice versa. He can do computer model. Where is it? He can do computer model. Is a computer model. He can do computer simulation model and test using physical model, or test using, come back and check manually, calculate using the analytical equation which is already there, check whether the same power is being produced or relatively equivalent power is produced by his new engine or not. Performance is relatively similar to this or not. Like this, you have to develop your ideas into proper design. So start with mathematical model. You can just use the equation to solve or design, and then such models can be based on scientific theories or laws that have stood. It is already proven by your Pascal or your Einstein or Newton's or Steinman's or what else? Mechanical, I really don't know. Coulomb's, simple one. All these people are already done. Newton's already done. Ohm's already done his research and come out with the equation already. No, it's already done. They may be based on empirical. Empirical, what is empirical? Quickly. Mathematical models are usually employed for simple system, right? And this is so static model, and mostly they are all not, you know very well, right? Or in future, if you go for master degree and projects are real project, you may find all these analytical methods are foolproof, not viable. It can form the basic, it can be used for troubleshooting, but not useful for real life problems, solving real life problems. In that case, you just start with defining and do preliminary designs using these equations. Go for testing using simulation models or physical models. See whether they are really performing well, and then you can complete your design. Confirm your design, complete your reports, go for implementation and monitoring. Right. Come on, I ask one more question. Empirical equation. What is empirical equation? Where is it? Empirical equation. Data. There is a limit constraint there. You should be knowing. Empirical data. Empirical data means site specific, only applicable for that region. Scientist A, engineer A, or economics A has done analysis for his own, taking his own catchments, his own people, his own region, communities, and analyze and come out with the result. So they are all site specific. You cannot depend on their solutions or data. So be careful when you do based on these empirical data or relations or their equations. Or add your own coefficients, modifier, or numbers that can be adapted in your region, so that you can still use this. Modify this equation, adjust the variable that can accommodate your own problem, then you can use it. So number 1 is the mathematical model, number 2 is the computer simulation model, number 3 is a physical model. These are the ways you can put your ideas, transform your ideas into a proper design, prototype model, or a method, and so on. After all done the design, go for evaluation, selecting a preferred solution. Criteria to evaluate and select the preferred solution include prototype testing and scale modeling. Yeah, preferable, always it is preferable. Having designed your problem using mathematical models and computer models, go for prototype testing and scale modeling. That will completely evaluate, put an end or decide your parameters design for a new product, new engine, new machine. Do that way, evaluate it. Don't leave just after testing, forget. No, must go for one more step to evaluate your solution, making it like the gentleman written here nicely, to make a final decision. The student has written, I don't remember, Mahmoud, I think, judgment, make a final judgment, you should evaluate. That could be by a prototype. What is prototype? Come on, quickly. Identification of weak areas. What is prototype? I don't know a lot of these engineers. Sometimes you read, you get lost. They use this word interchangeably.
Prototype is
Define like project like can
answer.
Yeah, please. Prototype is
unrefined or unfinished, or like the first copy, or like the first edition.
no. Did you study? Anyone study hydraulics? Hydraulics, mechanical engineer, fluid mechanics, hydraulics.
Sample product.
No. You studied
It's
about
like a minimized sample from the main object
that
or
is scale
project.
model. That is scale model. Miniature of reality is scale model. Prototype is a real structure. This you would have studied in your models and similarity analysis in fluid mechanics or hydraulics or any mechanics subject. That means this kind of word is interchangeably used. I'm so sorry for that. The real meaning of prototype is a real structure, like you construct a dam, you construct a hydro plant. The plant at the site is called prototype, right? And then the scale model that you have used for analysis at the lab, at the maybe sometimes if you are analyzing an ant behavior of the ant, the flies, this in the small objects. In that case, prototype and scale are same. You can call that as interchangeably scale or prototype because the proportion is same. But construction of dam, construction of power plant, construction of building, it involves a scale model, right? In that case, you have to differentiate this scale model from a real structure. Hence, real structure is called as prototype. Okay. In some publications, somewhere they use even the model as a prototype, tabletop model as a prototype. That's a wrong slang, wrong word. Okay. But make use of this prototype for your real structure. It's a it's a portfolio, means existing one, real one, right? Scale model may be a proportion of this prototype. Why it's written as prototype and scale modeling? For small object, you have to really go into that actual subject object to do that. It's easier. You cannot analyze the insect always through the microscope. Must have a big, sometimes it's a bigger. Scale models may be bigger than the actual size. So use either the real structure or a mimic or what do you call the duplicate miniature version, right? The miniature version or the model, the replica of the prototype to evaluate your solutions obtained through your design and testing. Come on. And then identifying weak areas. Yeah, when you do that, you can identify. Maybe you are testing a car, which is the very good sport car on the race course, which can be the best car. In designing the best car, you have to control all these fluids and all these mechanical things, hydraulics things to design it. In doing so, maybe your speed have to be adjusted. Maybe your material has to be changed. Maybe your design like 3 wings, 4 wings, right? Or the front portion should be some more lower than the back portion. All these changes and modification you can identify while doing this evaluation as well, in addition to testing. For products, this is important point. Just now we are talking about evaluation. In the evaluation, you cannot just test it, right? For products, criteria may also include safety, cost, reliability, consumer acceptability, right? For products, these are all things common for all types of designs and construction and implementation. But when it comes to products, you must go one more step to evaluate for its safety, right? Cost effectiveness, marketability, reliability, sustainability, consumer acceptability, right? What is the market survey, result of the market survey? Then only you can launch the product, otherwise you end up with loss. This has to be done in the prior to the project itself. But once you finish your model, it may be of its own design and maybe some changes, but test for with the final product, test for its safety, cost effectiveness, reliability, and reliable means how much, how long it can be used, right? Reliability, the length of life, the life period, or and the duration that it's going to be in the market. And then consumer acceptability, right? Whether it is feasible, attracting, need, all these things you have to check in addition to evaluation of the physical model. Okay, I stop here. Any question you can ask me. I just open up the quizzes. Any question? All of you open this file, quizzes.com. Quizzes. Is it okay? Are you ready? All of you go to this website, quizzes.com, and then I will upload the question. At the end, you have to tell me, please give comments, very important. You have to give comments on the class, internet connection, the flow of lecture. I remind you, I post on YouTube. You can control, if you feel some students may feel my talk is faster, you can control the speed there. Just control the speed, change normal to slow, a bit slow. You can still understand, right? At times I may go fast. I will try to minimize, but you can still benefit from this YouTube version. You can reduce the playback. Go to playback button there, the 3 dots. You can adjust the speed to listen if you want, right? So let's take this sustainability. I want to do there are about 5 to 6 questions only. You can quickly complete before 3:30 and go for another class if you have, or end the class. Come on, let me start it. Are you ready? Okay, I take from the file.
Yes, teacher.
Publish. Okay, I share screen now. Start the quiz. Keep giving your comments, and I don't know because I'm not receiving. You should be knowing whether my voice audible, class is okay, the flow is okay, content is okay. If any question not clear in the quiz is also, you can tell me. Sir, I'm not clear with this. What is the answer? You can discuss. That's the purpose of conducting. Come on, take this. Join a code also there. Let me post it. Join me quizzes. Okay. Also given to you. Okay, let me start the quiz. Sorry, time up. We have to close on time. Huh? Please cooperate. You can still join and do it. Let me start the quiz. So finish we can leave the class. Completing quick, we can leave. Give your actual name. Let me know who is the champion. Give your actual name. Go from Eliza, Ozzy, Lina, Yao. Give your full name. I mean the name. Yadu. Amul, jump high jump. Take it easy sportively. Don't worry, I'm not barking. It's an exercise. Remember points, score points. Let's stop. Are we done? Time up already. One more minute. How many of you finish? Some 6%. Okay, stop here. The class ends here, and I was asked to close it sharply. Start sharply. Please help me. Have you done? I think most of you have done. Okay, you can still continue. Let me end the class now. If you want, you can continue. Let me end the class now.